Good day, everyone. So today I am assigned to present my report. In this screencasting of mine, I am going to present my report about the processing of data analysis and interpretation, which includes the subtopics: processing data, categorization, coding, application of statistical tools, and preparation of tables and graphs. Now, to begin with, let us first tackle about processing of data. So in processing operations, we have to thoroughly understand the four different areas of it. We have editing, coding, classification, and tabulation. Okay, to begin with, let us talk about editing first. So editing of data is a process of examining the collected raw data, especially in surveys, to detect errors and omissions and to correct these when possible. So editing is done to assure that the data are accurate, consistent with other facts gathered, uniformly entered, as completed as possible, and have been well arranged to facilitate coding and tabulation. So we have two kinds of editing. We have the field editing and we have the central editing. So what's the difference between the two? Let's talk about it. So let's start with the field editing. Field editing consists in the review of the reporting forms by the investigator for completing, translating, or rewriting what the latter has written and abbreviated and or in illegible form at the time of recording the respondent's responses. So this type of editing is necessary in view of the fact that individual writing styles often can be difficult for others to decipher. Central editing, however, should take place when all forms or schedules have been completed and returned to the office. So this type of editing implies that all forms should get a thorough editing by a single editor in a small study and by a team of editors in case of a large inquiry. I hope everything is clear about editing. So let's talk about coding now. Coding refers to the process of assigning numerals or other symbols to answers so that responses. Okay, I hope everything is clear about editing now. So now let's talk about coding. Coding refers to the process of assigning numerals or other symbols to answers so that responses can be put into a limited number of categories or classes. So why is it necessary? Why is it so important in our research paper to be included? So coding is necessary for efficient analysis, and through it, the several replies may be reduced to a small number of classes which contain the critical information required for analysis. Coding decisions should usually be taken at the designing stage of a questionnaire, and it makes it possible to pre-code the questionnaire choices, which in turn is helpful for computer tabulation, as one can straightforward key punch from the original questionnaires. Now, going ahead, we will now touch about classification. Classification of data, which happens to be the process of arranging data in groups or classes on the basis of common characteristics. So data having a common characteristic are placed in one class, and in this way the entire data get divided into a number of groups or classes. So as you can see here, there are two types of classification according to attributes and according to class interval. So what does it mean according to class attributes? So this is when data are classified on the basis of common characteristics, which can either be descriptive, such as literacy, sex, honesty, etc., or numerical, such as weight, height, income, etc. However, according to class interval, we just have to think about the exclusive types and the inclusive types of your data. Now, what does it mean, exclusive type class intervals? So they're usually stated as follows: 10 to 20, 20 to 30, 30 to 40, 40 to 50. The above interval should be read as under 10 and under 20, 20 and under 30, 30 and under 40, 40 and under 50. So an item whose value is exactly 30 would be put in 30 to 40 class interval and not in 20 to 30 class interval. However, in inclusive type class intervals, they are usually stated as follows: 11 to 20, 21 to 30, 31 to 40, 41 to 50. Thus, an item whose value is 20 will be put in 11 to 20 class interval. Okay, now let's talk about tabulation this time. Tabulation is a process of summarizing raw data and displaying the same in compact form. Example, in the form of statistical tables for further analysis purposes. In a broader sense, tabulation is an orderly arrangement of data in columns and rows. So why tabulation is an essential part of your research study? It is important because of the following reasons. It conserves space and reduces explanatory and descriptive statement to a minimum. It facilitates the process of comparison. It facilitates the summation of items and the detection of errors and omissions, and it provides a basis for various statistical computations. So, what are the generally accepted principles of tabulation? So we have, I think, 13 of them. So we have to keep in mind that every table should have a clear, concise, and adequate title, and this title should always be placed just above the body of the table. Every table should be given a distinct number to facilitate easy reference. The third principle is the column headings or captions, as we call it, and the row headings or the stubs of the table should be clear and brief. Number 4, the units of measurement under each heading or subheading must always be indicated. Fifth principle, explanatory footnotes, if any, concerning the table should be placed directly beneath the table, along with the reference symbols used in the table. The sixth one, source or sources from where the data in the table have been obtained must be indicated just below the table. The seventh one, usually the columns are separated from one another by lines, which make the table more readable and attractive. So those columns whose data are to be compared should be kept side by side. Similarly, percentages and or averages must also be kept close to the data. The ninth principle, it should be considered better to approximate figures before tabulation, as the same would reduce unnecessary details in the table itself. The 10th principle, it is important that all column figures be properly aligned. Decimal points such as plus sign and deduct signs or minus signs should be, or positive or negative signs should be in perfect alignment. Abbreviations should be avoided to the extent possible, and detail marks should not be used in the table. So we all know about the detail marks, right? The dot, 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 kind of. And the 12th principle talks about miscellaneous and exceptional items, if any, should be usually placed in the last row of the table. And the last one, the arrangement of the categories in the table. And it should be in chronological, geographical, alphabetical, or according to magnitude to facilitate comparison. Now, let's talk about the analysis of data. Okay, these are the measures of central tendency which we should be familiar with. The measures of central tendency are mode, median, and mean. So we will be also discussing about the shape of the distribution and a consideration for choosing an appropriate measure of central tendency. So what does it mean? What is a measure of central tendency? A single central value used to summarize a distribution of score is what we call the measure of central tendency. It is a calculated it is calculated using mean, median, or mode based on situation. It is using any one of the three calculation methods. To the left, the data is eventually distributed about the B, therefore the central tendency of the data is a B. Okay, for example, using any one of the three calculation methods to the left, the data is evenly distributed about the B, therefore the central tendency of this data is B. Okay, now as you can see, for example, at the picture right here, okay, we have B, B, A, B, 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 C, C, okay. So here we're using any of the three calculation methods to the left, so the data is evenly distributed about the B, therefore the central tendency of this data is B. Now let's talk about each and every calculation method. So we have the mean. The mean is the arithmetic average obtained by adding up all the scores and dividing by the total number of scores. So we have the formula right here. I am not a mathematician, so let me just try to impart this as much as I can. So y here, the solution y here is what we call the y bar, and it represents equals the sum of all the scores, and y here is divided by the number of the scores, which is n, okay, which is the number. Now, what about the median? Median is the value of the middle item of series when it is arranged in ascending or descending order of magnitude. So it divides the series into two halves. In one half, all items are less than median, whereas in the other half, all items have values higher than median. Now, what about the mode? The mode is the most commonly or frequently occurring value in the series. The mode in a distribution is that item around which there is maximum concentration. So mode is a positional average and is not affected by the values of extreme items. So let me show you an example. Now, we find the mean, median, and mode of the ages of the teacher's age is 50 and is added to the data set. So we have 11, 12, 11, 11, 12, 11, 11, 12, 11, 13, 50. So the mean is supposed to be presented this way: 11 plus 12 plus 11 plus 11 plus 12 plus 11 plus 11 plus 12 plus 11 plus 13 plus 50 is equals to 165. Now 165 divided by 11 is equals to 15, so the mean is 15. Now, in median, it has to be presented this way. Median is simply talking about the order. So according to the data set, let's just have to arrange it into its order form. So we have 11, 11, 11, 11, 11, 11, 12, 12, 12, 13, and 50. So the middle number is 11, so the median is 11. Now, talking about the mode, 11 appears most, so the mode is 11. Another example, as you can see here, it's a complicated data. Now, I'm not going to talk about this, but you can see it from here. It came from a study talking about hourly wages of employees at the local restaurant. So as you can see, this is how they get the mean, the median, and the mode. Okay, so the central tendency measures, these are the formula as I have mentioned earlier. So the mean, this is the formula. It talks about the balance point, median. This is the formula. It talks about the middle value when ordered. In the mode, it doesn't have any formula, but it is used to know the most frequent value gathered from a data set. Okay, now let's talk about the measures of dispersion this time. So important measures of dispersion are range, mean deviation, and standard deviation. So what does it mean, range? Range is the simplest possible measure of dispersion and is defined as the difference between the values of the extreme items of a series. Thus, range is the highest value of an item in a series minus the lowest value of an item in a series. So as you can see here, we have 38, 46, 54, 56, 62, 64, 65, 68, and 77. So it talks about the height inches here. Okay, going back there. So the range, 77 is the highest and 38 is the lowest. So the range as how we see it is 39. So as you can see, the scale of measures by inches ranges from here until here. Okay, now let's talk about statistical tools. So this is the sequence of presentation when it comes to your statistical analysis. So we have statistics, defined, correlation, hypothesis, the chi-square test of independence, regression analysis, factor analysis, and of course the references. So let's discuss this one by one. Statistics defined. Statistics is the science and practice of developing human knowledge through the use of empirical data expressed in quantitative form. It is based on statistical theory, which is the branch of applied mathematics. Within statistical theory, randomness and uncertainty are modeled by probability theory. So this is what statistics is for. It is used for collecting, summarizing, and analyzing of data. So the term also refers to raw numbers or stats and to the summarization of data. So example, the frequencies that we just discussed a while ago. Let's talk about correlation. Correlation allows an examination of the relationship between variables. So is there a relationship between these variables? Are they positively or negatively related? A correlation coefficient of O or 0 means that there is no relationship between the variables. So negative relationship or positive relationship. As you can see, negative relationship is presented with the sign, negative sign, and the positive relationship doesn't have any. So it's just a normal number. Important correlation is not causation. Correlation is not causation, which says that a correlation does not mean that one thing causes the other. There could be other reasons the data has a good correlation. Example, what is the relationship between exercise and depression? Does depression increase when exercise increases? So does depression decrease when exercise increases? Is there no significant correlation between exercise and depression? So correlation is positive when the values increase together, and correlation is negative when other value decreases as the other increases. So as you can see it from the illustrations below. Now let's talk about hypothesis. Null hypothesis, this is a hypothesis but put forward to argue that a relationship or pattern does not exist. An example of this is the cholesterol study example. In a randomized control trial, the control group and the treatment group have equal levels of cholesterol at the end of the study. So the null hypothesis, group A and group B are equal, denoted by hypothesis. Alternative hypothesis, statement of what study is set to establish. So alternative hypothesis example, group A and group B have different levels of cholesterol. The null hypothesis will be true if the findings are significant. However, the null hypothesis will be false if the findings are significant. So let's talk about hypothesis alpha. Alpha level or significance level is the value that is determined by the researcher in order to reject or retain the null hypothesis. It is a predetermined value, not calculated. In other words, if we select a value of 0.05, findings would be deemed statistically significant if they're found to be 0.05 or less. What does that mean then? Alpha indicates the probability that the null hypothesis will be rejected when it is true. In other words, the null hypothesis is wrongly rejected. This is called type 1 error or alpha error. Example, in a trial of a new drug X, the null hypothesis might be that the new drug X is no better than the current drug Y. So the hypothesis, there is no difference between drug X and drug Y. So a type 1 error would occur if we conclude that two drugs produce different effects when there was no difference between them. Now let's talk about hypothesis beta. Beta is the probability of making a type 2 error when testing hypothesis. Type 2 error is failing to detect an association when one exists or failing to reject the null hypothesis when it is actually false. You kept the null hypothesis when you should have, you kept the null hypothesis when you should not have. Now, now let's talk about hypothesis beta. Beta is the probability of making a type 2 error when testing a hypothesis. Type 2 error is failing to detect an association when one exists or failing to reject the null hypothesis when it is actually false. And then you kept the null hypothesis when you should not have. Say, for example, if drug X and drug Y produce different effects and it was not concluded that they produce the same effects. Now let's talk about chi-square test of independence. What does it mean? What is this? Now let's talk about chi-square test of independence. What is this test all about? The test is applied when you have two qualitative variables from a single population. It is used to determine whether there is a significant association between the two variables. For example, in an election survey, voters might be classified by gender, male or female, and voting preference. We could use a chi-square test for independence to determine whether gender is related to voting preferences. So we have male here in this table, female in the column total. So as you can see, we have the total row and we have the different departments right here and presenting the different numbers right here. So when to use chi-square test for independence? The test procedure described in this lesson is appropriate when the following conditions are met. The sampling method is simple random sampling. Each population is at least 10 times as large as its respective sample. The variables under study are each categorical. If sample data are displayed in a contingency table, the expected frequency count for each cell of the table is at least 5. Now let's talk about regression analysis. So what does it mean, regression analysis? Regression analysis is used when you want to predict a continuous dependent variable from a number of independent variables. Regression analysis is widely used for prediction and forecasting. Classical assumptions for regression analysis include the sample of representative of the population for the inference prediction. The error is random variable with a mean of 0 conditional on the explanatory variables. The independent variables are measured with no error. The predictors are linearly independent. Example, it is not possible to express any predictor as a linear combination of the others. The errors are uncorrelated, that is, the variance the the errors are uncorrelated. The variance of the error is constant across observations. If not weighted, least squares of other methods might instead be used. And so this is how the regression analysis is being presented. So this is an illustration of linear regression on a data set. Now let's talk about other analysis, type of analysis, which is the factor analysis. So factor analysis is a useful tool for investigating variable relationships for complex concepts such as socioeconomic status, dietary patterns, or psychological skills. It allows researchers to investigate concepts that are not easily measured directly by collapsing a large number of variables into a few interpretable underlying factors. So what is a factor then? The key factor, what is a factor then? A key concept of factor analysis is that multiple observed variables have similar patterns of responses because they're all associated with the latent example, not directly measured variable. For example, people may respond similarly to questions about income, education, and occupation, which are all associated with the latent variable, socioeconomic status. So this is a good example of factor analysis. So this is coming from a study. Okay, this is how it is being presented. Now let's talk about the presentation, which is the last part of my report. What does it mean, presentation? Presentation is the process of organizing data into logical, sequential, and meaningful categories and classifications to make them amenable to study and interpretation. There are three ways of presenting data. We have textual, we have tabular, and we have graphical. Now let's talk one way after another. Okay, now let's talk about textual. Textual are statements with numeral or numbers that serve as supplements to tabular presentation. Now, what is a tabular presentation? Tabular presentation is a systematic arrangement of related idea in which classes of numerical facts or data are given each row and their subclasses are given each a column in order to present the relationships of the set of numerical facts or data in a definite, compact, and understandable form. So there are two general rules regarding the independence of tables and text. The table should be so constructed that it enables the reader to comprehend the data presented without referring to the text. However, the text should be so written that it allows the reader to understand the argument presented without referring to the table. The third type of presentation is what we call graphical. So it is when a chart representing the quantitative variations or changes of variables in pictorial or diagrammatic form is presented. So there are types of graphs and charts. We have the bar graphs, we have the linear graphs, we have the pie graphs, pictographs, statistical maps, and radio charts, which we are so familiar with because we have already conducted series of researches before when we were doing our masters. Now, let's talk about the analysis. The analysis is a separation of the whole into a constituent parts. The process of breaking up the whole study into its constituent parts of categories according to specific questions under the statement of the problem. So we have two ways of data analysis. We have qualitative analysis and we have the quantitative analysis. So the qualitative analysis is not based on precise measurement and quantitative claims. So we have examples of qualitative analysis here. We have social analysis, from the biggest to the smallest class, most important to the least important, ranking of students according to the brightness. However, the quantitative analysis is employed in data that have been assigned some numerical value. It can range from the examination of simple frequencies to description of events or phenomenon using descriptive statistics, and to the investigation of correlation and causal hypothesis using various statistical tests, which we were able to discuss just a while ago. Now let's talk about interpretation. This section answers the question, so what? In relation to the results of the study, what do the results of the study mean? So this part is perhaps the most critical aspect of the research report. Interpretation is often the most difficult to write because it is the least structured. This section demands perceptiveness and creativity from the researcher. How do we interpret the results of our study? First, we have to tie up the results of the study in both theory and application by pulling together the conceptual or theoretical framework, and then review the review of literature and the study's potential significance for application. The second step is to examine, summarize, interpret, and justify the results, then draw inferences. And we have to consider the following: conclude or summarize. So this technique enables the reader to get the total picture of the findings in summarized form, and it helps orient the reader to the discussion that follows. Next is to interpret. Questions on the meaning of the findings, the methodology, the unexpected results, and the limitations and shortcomings of the study should be answered and interpreted. Next, we integrate. This is an attempt to put the pieces together. And often the results of the study are disparate and do not seem to hang together. In the discussion, attempt to bring the findings together to extract meaning and principles. And then we theorize. When the study includes a number of related findings, it occasionally becomes possible to theorize. Remember, we integrate our findings into a principle, we integrate a theory into our findings, and we use these findings to formulate an original theory. And the last one is we recommend or apply alternatives. In deducing interpretation from statistical analysis, the following keywords or phrases may be useful. Table A or B, C presents the so forth and so on. Table blank indicates the, as reflected in the table, there was, as observed, there was indeed, delving deeper into the figures, blah, blah, blah. The illustrative graphs or graph above, below shows that, and so forth and so on. Okay, this is the end of my presentation. If you have any questions, please just pin me up. You can also throw messages or questions on our thread if this is going to be posted on our Google Classroom. Thank you so much for listening. Have a great day.